Recording in progress.
Yeah, cams on everyone. Let's start off. Yeah, so last class we are doing how to find tension in a rope or a rod or anything. So basically, whenever you want to find tension, the story is simple. Wherever you want to find tension, cut it. Don't assume tension will be equal to the external force. So cut it, and then you'll get two pieces, and then choose any one part, and then draw the FBD of it. So let's see a few questions based on this. Cams on everyone. So let's say we have two parallel walls. And we got a chain here. So this is point A and this is point B. So it's like we have a chain here. This angle is your beta and this angle is your alpha, and the C is the lowest point. So this is a chain hanging between two parallel walls, but A and B are not at the same height. C is the lowest point of the hanging chain. Gravity is there. M is the mass of the chain. Find the tension at ABC. System is in equilibrium. It is at rest. So think. Take a minute or so. Start with the free body diagram. Let's start with the free body diagram. Let me help you a bit. So let's draw this chain. I'll just draw a line, okay? So I'll take the overall thing. So this is your point A. So how will the tension be? Remember, string always pulls. So TB will be this way. TA will be this way. C won't come in the picture because C is somewhere in the middle. And what is the other force? Mg. These are the three forces on the total that chain. Any other forces are there on the chain? Think of like this, no? If you're, if your person is hanging between, pull-up bar hota hai na? Someone is catching the pull-up bar and hanging like this. What are the forces on this thing? There will be only two hands, no? There. So there will be one tension, and weight, isn't it? There are only three forces. So it's like a man, catching a pull-up bar and hanging on both the sides. So these are the forces. What are the angles here? This angle is beta. So this angle is beta. This angle is alpha. This angle is alpha. So resolve into components. So this will be TB sine beta. This will be TB cos beta. This will be TA cos alpha. This will be TA sine alpha. Since this is an equilibrium, horizontal forces and vertical forces should balance. So in the vertical direction, TA cos alpha and TB cos beta are balancing the weight. In the horizontal direction, the TA ka sin alpha must be equal to TB ka sin beta. So far clear? Then there are two different tensions, right? A and B will not have same tension. They're not at the same height now. There's no symmetry there. So A and B will have different tensions. If alpha becomes beta, then you can say it will be equal. Then from here we can get TA, which will be, or you can take TB, it doesn't matter. So TB will be TA sin alpha by sin beta. Take this guy and substitute in this. Put it in that equation. Now I want to put TB, na? Put TB in this equation. Then your equation becomes TA cos alpha. That will become TA sin alpha cos beta by sin beta is equal to mg. If you notice this carefully, this will be sin beta cos alpha plus sin alpha cos beta. Isn't that sin alpha plus beta? Isn't it? Look at the numerator. It becomes sin beta cos beta. That is sin A plus B ka formula. I'm skipping that step. So check it out. So therefore, we'll get tension at A will be mg sin beta by sin alpha plus beta. If I got TA, then I'll get TB also. So you're done. So from here you can find TB also. So you can take this substitute here, aa jayega TB. Clear with this? How do you find tension at C then? Question is still not over. A and B we found out. Find the tension at C. C is the lowest point in the string. Think, I'll give you a minute more. This is what I was saying. If you ask me tension in the middle of the string, what should I do? I should cut it there and draw an FBD for that piece and then solve. Find the tension at the lowest point of the string. Now, listen to this thing. Whenever you want to find the tension in the middle, you cut it there. So this was a picture, right? This was B and this was A. C was the lowest point. So just assume you have cut it here. Now you'll get two parts, left and right part. You can take anything you want. I'll choose a left part. Answer will come same. So I'll choose a left part. So draw the FBD of only the F part. Now, what are the forces? Remember, C is the lowest point, so it will be a tangent will be horizontal. So TC will be this way, TA will be this way. This angle was alpha, this angle was alpha. So if you look at the components, this will be TA cos alpha, this will be TA sin alpha. What about this thing weight? The chain also will have some weight. Unfortunately, we can't find this because I don't know what is this length. So this is an unknown. We cannot find this weight of this part. If the chain had been alpha is equal to beta, I can say by symmetry it will be half of the weight. But we don't need it anyway. So the horizontal forces should balance. So TC must be equal to TA sin alpha. There I got TC from there. Because I already need TA ka value, substitute there, you'll get TC. Clear with this? Vertical, I cannot find, but horizontal, say we can figure out the value of tension C. You could have done the same thing with B also, you would have got the same answer. All clear with this? Now here, if you observe, you'll notice something here. We can do a little more theoretical on this. This is important. So this is the problem, Arya. If you take Lami's theorem, it works, but if there are more than 3 forces, then you'll start having problems. Now, previous case, so there are only 3, it worked out, but okay, it was right only. So look at this thing. When you take point A and point B here, you will notice something here. If you look at the components of A, this will be TA cos alpha. This will be TA sin alpha. It doesn't matter. You choose any point in the middle. You choose any point in the middle. If you take this angle to be theta, right, and you will see the tensions will be, so T is the tension at some random point. This will be T sin theta. This will be T cos theta. Here, if you look at the tension here, this is beta. This will be T sin beta. And this is T cos beta. Since horizontally there are no other forces, there is no gravity, nothing, you will notice tension in the horizontal direction at every point will be same. So the horizontal component of tension, so no matter where you cut the string, and if you get the tension there and take its horizontal component, it will be always constant. The tension at every point is changing, angle is changing, but T sin theta is not changing. So horizontal component of tension at any point on the string is constant. This will be more than one choice statement kind of questions. This is how they'll ask theoretical questions. So basically in this case, T into sin theta remains constant. T is the tension at a point and theta is the angle with the vertical. Clear with this? The product will always remain constant. T changes, theta changes, but the product remains constant. All clear with this? Understood how to do this chain questions? Because they're equal, Naresh Srihari. Why will they remain constant? What were you doing till now? That is the whole thing we're discussing. Na? Horizontal forces, if you see, TA sin alpha, and these two are equal. Na? Are there any other forces? So they should be equal. Similarly, if I take this one and this one, they two should be equal because they're in the, there is no other horizontal force. So at everywhere the horizontal force is same, isn't it? The verticals will change because of the weight of the chain, but weight will never act horizontally. So weight will not affect the problem. Clear with this, everyone? Let's see one more like this. So this is how you can do. A standard problem will be where alpha is equal to beta. That's your standard main cell problem. Advait, I can't see you, right? Your camera is blank. So adjust your camera. Let's see one more. Now you guys try this. This is let's get this. Try. You got 3 minutes. So we have a chain of mass 10 kg, 10 meter length is hanging on a smooth pulleys in equilibrium. So this whole thing is a rope. total length is 10 kg and 10 meter. Vertical particle length is 3 meter. Find the tension at the midpoint of the string. So I want tension here. Let's see how will you handle this. Anyone not clear with the picture, please ask me.
So what do they mean by the vertical part?
What do you think?
Sir, the
In
length,
this full picture, mein, what is the vertical part here?
sir, the one which is hanging away.
तो बस वही है ना. There is nothing vertical here, so that is the only thing. नहीं रे Samyak, that is wrong. Let's see. I know what mistake you're doing. You guys are ignoring. Nee, Shaurya, that is wrong. Nee, Aditi, that is wrong. Let's see. Let's look at the picture, okay? First of all, let's draw the FBD for each piece separately. It is mentioned in the question, the vertical particle length is 3 meter. Now see, 10 meter ka weight is 10 kg. So 3 meter ka weight will be 3 kg, right? So if you take the left side ka hanging part, let this point be, let's call it B. So here, this is the tension B. And here your weight will be 30 newtons because it's a 3 meter, so it will be 3 kg. So tension at B will be 30 newtons. Now look at this part of the string here. If you look at this part of the string here, that is not straight. It is at an angle. It is something like this. So now here, if you take these angles here, so tension at B will be tangential. This will be TB. This angle is theta. Unfortunately, I don't know what is that angle. Tension at A will be horizontal, right? So yeah. And how much is this chain? Now, if you look at the whole chain here, if this is 3 meter, this is 3 meter, then this piece will be 2 meter and this piece will be 2 meter. Everyone agrees with that length? If that is 2 meter, that means this weight will be 2 kg because it is 2 meters. So this will be 20 newtons. Now, if you look at the components here, this will be TB cos theta and TB sin theta. Once have a look at this FBD. Are you sure with this FBD? I draw two FBDs. The left part ka 3 meter, so weight is 3 kg. So 10 meter will give you 10 kg. That means 1 meter ka chain should give you 1 kg ka weight. The left side ka chain is 3 meter, so 3 kg. Now if you take the middle part, it is 2 kg, 2 kg. So if you draw the FBD, there will be three forces: TA, TB, and this particle own weight. There are three forces. Any doubts on this? The most common mistake, you don't take that angle. That is a problem. That chain is not straight. Now balance the forces. Vertical direction. Anyone not clear with the FBD, please ask. Like I keep saying, if you know how to draw the FBD properly, 50% of the problem gets over. FBD is the key. So TB cos theta, vertical na, TB sin theta is equal to 20 newtons. There is no other force. And TB ka value I already know. And in the horizontal direction, TB cos theta is equal to TA. So if I know TB ka value 30, so sin theta is nothing but 2 by 3. If sin theta is 2 by 3, then TB is 30 and cos theta is nothing but 1 minus sin square theta. So this will be 30 into root over 1 minus 4 by 9. That will be 10 root 5. That will be 5 by 9. 9 comes out 3. That is your tension at A. So B is the answer. I can even ask you more questions. Find the angle theta, find the tension at B, right? So you can play around like that. I can make it a more than one choice question, but there. Any doubts on the step, please ask me. That's how you analyze. You draw the picture. You draw for each piece separately and look at the forces. Anyone not clear with FBD? If you got the FBD, equations are fine. You'll get the hang from there. All clear with this? Shreyan, bolo na. Shaurya, Pratyasha, Arya, clear with this?
Yes, sir. Sir, actually, I took angles ka mistake I did.
Okay. Tanishka, Trishi, clear? Samyak, got your mistake? Shaunak, Ovia, clear na? Let's see one more. Shreyan, you have something?
Sir, due to net issues, I was not able to understand how we decided the 3 meter and the rest of the road 2 meter.
Because it was given in the question, God. What are you talking about?
Oh,
Read the question, na? It is there in the question. The vertical part is 3 meter. Total length is 10 meter. So what it should be? Read the questions properly. Examine. No one will come and help you with explaining the question.
sorry, sir.
You all are from, yeah, no, don't be sorry. I'm just saying. You all are from reputed English medium schools, right? Not some from potato school. So read English properly. You know why they call it a potato school? We used to have a potato school near our house. They used to feed potatoes in the afternoon for breakfast, lunch. So the name became potato school. Anyways, so let's say you have a string. So let's say we have a multiple strings like this, and you're hanging blocks here. M1 like a bunch of grapes, M2, M3, M4. This angle is theta, this angle is alpha, this angle is beta, this angle is gamma. So there are a lot of strings like this, and all these strings are perpendicular here. All these are strings. Gravity is there. So blocks are hanging. Problem, you know what happens? Sometimes when I explain a question, I give you too many details in the equation. So you get stop thinking. You don't think like, oh, this is what is happening. So that is important. So blocks are hanging from a series of strings. All these blue lines are strings, huh? So all these are strings, right? And so I want you to find tension in this string on the top. So let this be T. The T is the tension in the uppermost string. Find T in equilibrium. Picture is clear? How do we do this? Shaurya.
Sir, like, I did not understand the picture clearly. Like, could you explain it once again?
Which part you didn't understand? There are multiple strings here. There are blocks hanging there.
No, like, what is the condition happening? मतलब हो क्या रहा है, वही नहीं समझ रहा.
क्या हो रहा है? They are just hanging.
Okay, like, so multiple strings are hanging to one block, like that way.
हाँ, तो यहाँ पे 3 strings connected थे, यहाँ पे 3 strings थे, यहाँ पे 3
हाँ.
strings था, 2 strings था.
Okay.
It just joins there. You must be going ना, when you go to any function or party, कभी देखा वो lights arrange कैसा करते हैं? You have a bunch of lights, right? They're just hanging with wires.
Yes, sir, Diwali के lights जैसा type.
Yeah. How do you find the tension in that uppermost string? This is the type of question which will scare you, but easy to solve. So if this kind of a question comes in the exam, you know what I will think normally, what I used to think. Okay, there's an alpha, beta, gamma, theta, m1, m2, m3, m4. Like bloody, this thing has so many equations, right? If I try to draw an FBD also, I'll get three forces. So this thing, if I try to solve also, this will easily take 10 to 15 minutes. But the examiner has given this exam in a mains exam. That means he is expecting me to solve this in a minute or two. That means there must be an easy way to do. You're getting it? I don't know what to do. First, I will convince myself I can do this in a pretty fast way, and then I'll start thinking about that easy way. That is important. You should always have that trust, the confidence hona chahiye. I can do this in an easy way. When you start thinking that, your brain will figure out an easy way. But as long as you get scared, right, and you think like, oh, it is looking dangerous and deadly, you will scare yourself. Tell me one thing, in the night, right, why do you get scared? Like, why do you think about a ghost or something, and why do you get scared? Technically, there is no ghost. You scare yourself. All masses are different.
Sir,
Oh, you got it. Aditi.
on all the strings that parallel to each other, na?
ये तो 90 है.
हाँ, फिर, oh, wait.
This is 90. Maybe I'll drop big if you want. Think I'll give another 30-40 seconds. You can do this in less than 30 seconds. You have one answer though. Nah, nothing to do with angle. The angles are messed up. नहीं रे सिद्धेश. Right over here. Always remember, it always depends on what is your system. If you take your system properly, your life becomes easy. You want to find the tension in the upper string, right? Then choose the 4 blocks as one system. Take this whole thing as one system. So if I just put a blanket on top of it, don't know what is happening inside, right? If I take this whole thing as one system, the green box, and if I ask you what are the forces, what will you say? You have one force here, tension T, making an angle theta. We have one tension here, T1. We have one tension here, T2. We have one tension here, T3. And from inside, I don't know what is inside, but I know the total weight is M1 plus M2 plus M3 plus M4 G. Isn't this how it will look? If I just take the whole thing as one system, you'll see a green box, and you will see there are 4 weights and 4 tensions. And if you look at the components here, this will be T sine theta, and this will be T cos theta. There is only one force which is balancing the weight, that is your T sine theta, which is M1, M2, M3, M4, G. Therefore, tension will be Done. Is that making sense? So depending on what you take as a system, your life can become easy. Instead of trying to solve each and everything, you can do this. What if I ask you to find the tension in this string? Then I'll take this as system, no? Like I keep saying, na, wherever you want to find tension, cut it there. So if I cut it here, I'll take this whole thing as one system. So this tension will be these three weights ka component. If you want here tension, I'll take this as a system. So wherever you want to find the tension, take only that part as a system. Is this making sense? There is only one person here who is actually balancing the entire weight, and that is this t sine theta. There is no other vertical force here. Right, Utsa? Now you're getting it. Easy? Clear? This would be a proper mains level question. Not tough. You can solve this in less than a minute, but you should know what you're doing. Any doubts on this? So there's a few equilibrium problems. We have seen more varieties in vectors. You can refer there. These are some of them. So always, whenever you're drawing an FBD, ask yourself, what is my system? That will change a lot of things. Don't blindly draw whatever you think it is there. Any doubts? Clear with this? Going ahead. Next one. Steps to solve the problem. So in NLM, if you give me a problem, normally what is the process? Remember this, always by heart the process. Don't by heart the problems. Because if you know the process, no matter what problem I'll give, you will know how to handle that. Even if something changes in the problem, you'll understand how to, modify the process. But if you mug up the problems, you will have an issue. So have some standard steps. It's like, always have a plan. Even if don't go according to the plan, you'll know how much you're going wrong, isn't it? If you have a plan to go from A to B, right? And when you're going like this, you have deviated from the plan. But unfortunately, when you don't have a plan, you can go like this. Yeah, this is also right only. When there's no plan, every path is right. So steps to solve. So first one, choose your system. So there are 10 blocks. You can choose all 10 as one system. You can choose only one block as one system. You can choose anything you want. And draw FBDs with appropriate symbols. How to draw an FBD? For that also we wrote steps last time. So if this was programming, right, it was like a nested program. You have a program which you have inside another program. This program will call these instructions and fill up this result here. So it's kind of like that. So draw FBDs with appropriate symbols. And how to draw an FBD, we have steps for that. You already know how to do FBDs. We have done that in detail. Second thing, now since they are moving, assign accelerations. If there are 4 objects moving, assign accelerations A1, A2, A3, A4. Assign accelerations and find the relation between them using constraint motion. Step 3, choose your coordinate axis. Choose anything, any 2 perpendicular directions as X and Y axis. We have seen this in kinematics also. If you have inclines, choose the incline as X and Y axis. Normal ground, just take plane X and Y axis. Choose your coordinate X axis and resolve forces and accelerations along them. This is from vectors, resolving components. Generally, mass remains constant. So you can apply F is equal to ma bar along the axis. This is the Newton's second law of variation. And solve. That's it. You know each and every step. You know how to draw an FBD. You know how to find constraints. You know how to resolve components. You know how to write equations. You know how to solve. This is your process. It doesn't matter what kind of problem I give. This is the process. You're getting it? So process will not be something out of the world or something. It will be pretty standard definitions, but that's how you start. So we will start moving things now. Clear? Let's go ahead. Any doubts on these steps, please ask me. Have a look at them once, read them. Can I go ahead? Going ahead.
Yes.
Let's start off with some easy ones and then we'll slowly bump up. So we have two blocks, M and 2M, and you're applying a force F. Floor is smooth. Find the acceleration and the normal reaction between them. Same question, M and 2M, but this time you're applying force from the right hand side. There, get them both. Easy one, but try. Take a minute and figure it out. First part, then I'll show you. Right, Arya, get the next one also. Yeah, it's a standard one. Most of you are getting the first part, I guess. Acceleration is fine. Get the normal reaction. What is MA, Rishi? What is A? The question is that only. Find A. You're giving me an answer in terms of A. Answer must come in terms of F and M, isn't it? Right, Ovi. I get the next part also. And let's see the first part. Step 1, choose your system. Now here, see, I can choose anything as a system. I will choose both the blocks as one system. I can do that. M and 2M. So here my system is both the blocks. You're applying force F. Second, assign acceleration. Since both are touching each other, they'll have same acceleration A. Step 3, write F is equal to ma. So force is equal to total mass 3m into acceleration. We get acceleration is equal to F by 3m. Great. Second thing, you want to find the normal reaction. Now, if you want to find normal reaction, you have to split it because n is there in the middle. Now you can choose any one of them. I can choose either m or 2m. I'll show for both of them just for your reference. Now draw the FBD of both the blocks separately. Normal reaction will push you. So this is how the FBDs will look, everyone. I'm only taking the horizontal forces. Accelerations will be same because they're in contact. So this will be F minus N, right positive, left negative. We'll keep the convention simple, mass into acceleration. Remember, the formula is net force is equal to mass into acceleration. Some people do this thing, they write like this, F minus N plus ma is equal to 0. Don't get confused. Ma is not a force. Net force is mass into acceleration. Here the force N is equal to mass to m into acceleration. So F minus N, mass, acceleration is F by 3m. We get N is equal to 2F by 3. N is equal to 2F by 3. See, you get the same answer. It doesn't matter which block you take. You take the left block or the right block, answer will come. For you to understand, I'm doing both of them, but normally we will just draw only one of them. Are you getting the steps? What about the second one? M, 2M. So force will be F, right? So now this time they will go to the left-hand side. So force is equal to 3m into acceleration. So acceleration will be still same. It doesn't matter. Net force is same. Total mass is same. Now you want to find the tension in the middle. So you need to draw an FBD. So cut it in the middle. Simple. You want to find normal reaction, you want to find tension, you need to cut it there, or else it will become an internal force. Matlab the forces will become equal and opposite. You can't figure it out. So this is M. This will be the normal reaction. There's only one force. And if you observe one thing, see how I'm drawing the FBDs. The forces will be on the body, accelerations will be outside the body. Getting it? Keep your picture clear. Don't mess up, everything on the same picture. It gets confusing. Draw the forces on the body and draw the accelerations outside the body. There's only one force, N is equal to mass into acceleration. And acceleration is F by 3m. This was easy. All clear with this? You're getting how we did this? Any doubts? FBD, or why did it take N like this? Anything that you're not convinced, please ask. Let me give you one more like this. You tell me what is the answer for this one. Can I turn the page? All sure with this? Srihari, clear, na? Siddesh, Shaurya, Utsa, Vanshika, clear? Let's say we have multiple blocks, M, 2M, 3M, 4M, 5M. And someone is pushing with force F. Smooth ground. Find normal reaction between 3M and 4M. Technically this we should draw, but since the block is moving only left and right, it is not necessary, right? Technically I should have drawn it, but they won't affect the acceleration in the horizontal direction. That's why I'm not drawing it. So I would have drawn like this. So N ground and this will be 2mg. Since they're not affecting the problem, I ignored it. So, but yeah, I should have drawn the technical. Clear? So if the block was going up and down, I would have taken care of it. Because it is only going left and right, I ignored it. Another way of asking the same question is like this. Let's say there are 100 blocks. This is block 1, block 2, block 3. This is block 60, and this is block 61, and this is block 98 and block 99, 100 blocks. 100 blocks are connected by string and pulled by a force F. Find tension between the 61 and the 60th block. It's like your train. There are 100 compartments. But the similar questions, similar modulators. 3F by 5. I don't want acceleration, right? I want normal reaction. 9F by 15. You can simplify that more, na? Yeah. 3F by 5 aega. 7F by 15. 2F by 5. 0.4F. Let's see. Get the D part also. There are 100 blocks connected by a string and someone is pulling with force F like a train. Find the tension in the string connecting the 60th and the 61st block. Shaurya.
Sir, like in this case where there are strings that are connected, so like we'll just replace normal force with tension.
Can you just solve and give me the answer? Na? Why are you explaining all this?
No, I'm asking.
You're not asking, you're explaining, huh? Then?
No, like it would be the same thing, no, just it would replace with tension. I'm asking.
Do it, na? Why are you asking? Exam mein who will be there to ask?
Okay.
And where am I running away, Shaurya? After 2 minutes, I'm going to explain, na? So why are you asking? The problem I'll tell you with what asking. When you're asking, what you're telling your brain, boss, I don't trust my own knowledge. Unless someone tells me I'm right, I won't start solving the problem. You're sending a wrong signal to your brain. Exam, I will not be there beside you to tell you, Shaurya, you're doing right, let's go ahead. So maximum kya hoga? Do it, get a wrong answer, na? That is okay. So do it. You have an idea, try. I'm going to teach you anyway in 2 minutes, then you can see whether you got the idea right. If you got the answer right, your idea is right. Always
Sir,
remember that is important. No one is going to tell you your method is right. You have to try. Aditi.
in the second question, all of the masses are equal, right? M.
Same mass, same mass.
ठीक है.
Let's see the C part. Now, please ask if you have a doubt, but it's important. These are the things, you guys ignore, but these things will become a big problem later on. This is the reason why people write in the exam, they solve, they get an answer, but they don't mark. Because you don't trust yourself. So, small things. Tension force 19. Naresh, man, how did you get 99? 39. Okay, let's see. What about this guy? Step 1, choose your system. I'll choose the whole thing as one system. Step 2, assign acceleration. I'll assign acceleration. All are going together because they're touching each other. Step 3, apply is equal to F is equal to MA. F is equal to, what is the total mass? 15 m. Okay. I got the acceleration. Great. Next, what do you want to find? You want to find the normal reaction between 3 and 4. So cut it. When I cut it, I'll get 2 pieces. I can take 1, 2, 3, or I can take 4 and 5. It is your choice. I will take 4 and 5. You can take 1, 2, 3 also. So now your system is 4 and 5. So again, start the process. Draw the FBD. There is one normal reaction. I'm not writing the normal reaction on the ground because it's not moving anyway. Forces will be on the body. Accelerations will be outside the body. There's only one horizontal force. So N is equal to total mass, 4m plus 5m into acceleration. Acceleration is F by 15m. mm goes off 3F by 5. Easy. Is the process clear, everyone? I could have taken the left one, then the FBD would be F minus N is equal to 6MA. You would have got the same thing. Doesn't matter which part you take, the answer will come same. Any doubts on C part? Can you do this 100 blocks wala thing? Find the tension in the 60th and the 61st block. Hmm. 3F by 5, that might look right. Again, step 1, choose your system. Start with the process. I'm telling you like a broken tape recorder. Start with the process. Choose your system. What is my system? I will take all the 100 blocks as one system. Because why? They're all are going together. Acceleration be A. So we get force is equal to 100 m A. So acceleration is F by 100 m. Great, I got the acceleration. Next thing, you want to find the tension between 60 and the 61st block. Right, Aditi, you got it. So cut it here. You want to find tension here, cut it. Now, when you cut it, you'll get 2 pieces, the left piece and the right piece. You can choose any one. So I'll tell you one thing, a better way to think of like this is, if you're going to treat all this as one system, can I just make that all thing into one big block of 40 m and make this whole thing into one big block of 60 m and you're applying force? Isn't this how the question becomes? Treat that entire tail as one block and treat the entire head as one block. They become a 2 block problems. And now I'm asking you to find the tension here. So cut it there. You can take any one. I will take the 40 block. There's only one horizontal force, tension. And this is your acceleration. So we get T is equal to 40 m into acceleration. That will be 40 m into F by 100 m. That would become 2F by 5. It's not 3, right? It's 2F by 5. Right over here. Check karo Aditya. I think that was 2F by 5. This mass is only 40 m. Suppose you want to take the other block and show you. If I take the other block, uska FBD will be like this. This will be F and this will be T and this will be the acceleration. So here the equation will be F minus T is equal to 60 m into acceleration. You get the same answer. Must have forgotten F. Any doubts on this thing? 100 blocks wala problem. All sure of this? Clear, na Arya? Devanshi? Clear? Rudransh? Shaurya? Got the same? Clear? Shriyansh? Srihari? Siddesh? Srihari? Clear with this? I think he got disconnected. Great. Let's see one more. Any doubts on this? Please ask. I'm going ahead. Clear na? Vanshika? Tanishka? Clear with this? Shreyan? Perfect. Next one. Let's say you have two blocks like this. This is 2m and this is m. This is angle theta, this is angle theta. You're getting, it's like you take a sandwich and you cut it diagonally. The floor is smooth. Now you started pushing from the left hand side with the force 2F and you're pushing from the right hand side with the force F. All surfaces are smooth. So the surfaces between them, this is also smooth. Find the normal reaction between them. Second thing, now if you apply this 2F and F, right, something will happen. What is the maximum value of F? So that the blocks do not slide over each other. What do you mean by that? Meaning, there is a possibility if you apply too much force, something like this can happen. You're getting what happened here? The block will start climbing this. You guys agree? There is a possibility, right? If you apply too much force, the both will just start going up on top of each other. I don't want this to happen. Then what is the maximum value of F? You can't, matlab, see, for acceleration, you can do that, Vanshika. Only for acceleration. But then when you want to find the forces, you can't do that. Because see, na, agar wo argument hai na, in this thing, what would have happened? Now, if I pulled with F and F, so net force is 0, so tension 0, but tension is not 0, right? So think of like this. If I take you and tie you with two elephants on both the sides and pull you with equal force, don't you feel tension? So tension is not the external force. Are you getting it? So whenever you two friends, right, is catching you and pulling your hands, you feel pretty uncomfortable, right? That is the tension. Your body is trying to get back to normal state. So even though your friends are pulling with equal force, the total force on you is 0. The tension is not 0. Let's get the first part. Find the normal reaction and find the value of F so that it does not slide. That is right over here. Get the second part. Second is the main question. Nahi, Siddesh. That's not the answer. Remember the process. Step 1, choose your system. Step 2, define your acceleration. Step 3, apply, forces resolve. F is equal to ma also. Try. I'll give you 2 minutes. You got an answer without theta, Aditi. That's what I'm saying. You know, see, it's okay if you don't know what is the right answer, but you should know when it is a blunder. Quite an important skill in life. Most of the times we don't know what is right, but you should figure out, boss, this looks like a big blunder. We have one answer for normal reaction. Anyone else? Acceleration was easy. I hope everyone got the acceleration part. 2f minus f by 3m. So you want to find the normal reaction, you have to separate them. You have to choose any one block. You can't take the whole thing. Siddesh, now the vertical में n we didn't take ना, now it will matter. अभी तो लेना पड़ेगा. Right हो गया. You got that. F by near होता है. You're pretty close. Numerator में you messed up something. Right आ गया. First part आया. Samyak first part आया. Let's see the FBD. So when you draw this, how is the normal reaction? Remember, normal reaction will be perpendicular to the surface. So n should be in this direction, everyone. This is your normal. It is not left and right. It is at an angle. So forces, that will be 2f. This will be f. This is 2m. This is m. I will take the whole thing as one system just to get the acceleration. So the net force will be 2f minus f. Total mass is 3m into acceleration. See how I'm writing it. Net force is mass into acceleration. Getting it? Because I have seen people do that. They write 2f minus f minus 3m. So acceleration is f by 3m. Great. You want to find the normal reaction, choose any one. Preferably choose the second one here because there's a second part of the problem. You'll see why taking the second one is better here. So if I take the FBD of this m guy, now look at the forces. We have normal reaction. It is like this. There is one normal reaction on the ground. There is one F from the right. You also have your own weight mg. Any other forces? These four forces are acting on the block M. And you're having acceleration A. This angle is theta. This is 90 degrees. So this angle will be 90 minus theta. So if you take n ka components, this will be n cos 90 minus theta. That will be n sin theta horizontally. N sin 90 minus theta, n cos theta vertically. These are your components. Now, if you take the horizontal direction, in the horizontal direction, what are the forces? N sin theta, right side, F is negative because it is left side, is equal to mass into acceleration. This will be N sin theta is equal to F plus MA. MA is nothing but F by 3. From here, I'll get the normal reaction, 4F by 3 sin theta. This is your N between them. Please check your angles. Any notes on the normal reaction, please ask. And others, do keep your cams on. This is the first part of the question. What is the second part of the question? Find the condition so that the block does not lift off. Tell me one thing. If the block lifts off, what will happen to the normal reaction here? Ng becomes 0, isn't it? If the block leaves the contact, that means it won't touch the floor. If it doesn't touch the floor, that means Ng becomes 0. So here in the vertical direction, if you look at the forces, there is no acceleration. We have Ng plus n cos theta minus mg is equal to 0. So we get n ground must be mg minus n cos theta, which is 4f by c sin theta cos theta. This is your normal reaction. this must be greater than equal to 0. This is your normal reaction of the ground. So I'll turn the page again. So if this guy lifts off the ground, the picture will look like this. That means here Ng becomes 0. If it slides up, it loses contact. Right? So to be in contact, normal reaction should exist. That means Ng must be greater than equal to 0. Equal to because you are just leaving contact. Ng is this guy. So Mg minus 4f by 3, that is caused by this thing. So that will be tan theta is greater than equal to 0. So from here we will get f must be less than equal to 3 mg by 4 tan theta. This is the value. Therefore, the maximum force you can apply is 3 by 4 mg tan theta. If you apply anything more than this, they will lose contact. Have a look at this page. Is the logic clear, everyone? Getting the steps? So if they start climbing on each other, the M block will lose contact with the ground. So that means Ng will become 0. Again, see, I did nothing new. I took the FBD, I drew the forces, I resolved the forces into components, I took the horizontal direction, I took the vertical direction, I solved. This is what I was saying. The process will not change whether I give an easy problem or a tough problem. Idea is the same. The only thing you need to figure out few things. Okay, it is losing contact with the ground, so Ng will be 0. Is this clear, everyone? Any doubts on this page? This is clear. What happens when you lose contact with the ground? Since you don't want to lose contact, the Ng must be greater than 0. Matlab it should exist. Clear? Take a break, come back by 9:38. Any doubts so far, please ask me. Anything not yet clear, not convinced with something here? FBD, equations, resolving forces, components. Chalo, come back in 5 minutes then. The normal quantum block ellipse powers. Nee, Utsa, you're getting confused. See, there are two different normal reactions here. There is this normal and there is this normal. So when it lifts off, these two are still sliding on each other, right? That is still in contact. The ground is not in contact anymore. Clear with that? Others, chalo, let's start off. Switch on your cams. Let's see one more. This is a good one. Again, finding these tensions and all, like I said, right, there are few chapters later on you will see. If you know how to find tension, half the chapter gets over. So this problem is something of that sort. Let's say instead of blocks, we have a rod here, or you can say a rope. This is a rod of mass m and length L. So someone is pulling this with force F. So let this point be x is equal to 0 and let this point be x is equal to L. Find the tension in the rod as a function of x, where x is the distance from the right end. There, two questions, get them both. So we got a rod of mass m, length L. Someone is pulling the first rod with force F, second is being pulled with two forces, 2F and F. Rod won't remain at rest, rod will start sliding now. Find the tension in the rod at a distance x from the right end. Get the second one also, Arya. Shaurya, get the second one also. Neerutsa, that's not the answer. Right, Samyak? Anyone else for the first one? Again, remember the process. Step 1, choose your system. Step 2, forces. We want to find tension somewhere, cut it there. Draw the FBD, solve. Okay. Right, Shaurya. Right, Arya. F is equal to T. You're saying tension is constant. Let's see the first one. So we have a rope here. You're applying force F. I will take the whole rope as one system. The whole thing is going together. So F is equal to ma. Next thing, you want tension somewhere here at a distance x. Now listen carefully. This is important. It's a pretty important question. It will come in a chapter called elasticity. So you want tension here, cut it here. When you cut this, I'll get two pieces, the right piece and the left piece. I will take the right piece. You can take the left piece also. Now, when you do this, the thing here is the mass has changed. This mass will be small m anymore, and this length is x. We can use unitary method. For length L, the mass is m. For x, it will be mass will be small m. So small m will be total mass by total length into x. That is the catch. The mass is not same. If you take a part of the rope, the mass will be different. Now, what are the forces? F minus T will be small m into acceleration. The acceleration is still the same. The whole thing is going with the same acceleration. Substitute here. F minus T, mass will become m by Lx and acceleration is F by m. Therefore, we get tension is F into 1 minus x by L. Check. This is how you do whenever they ask you to find tension. Got the process. So you want tension somewhere in the middle, cut it there. Whenever you cut, you get two pieces. Take any one, left or right, and then draw the FBD of it, and then try to solve. So the idea here is this: when you're cutting it, the mass will change for that particular piece. Now, using this logic, can you do the second part? Try. I'll give you a minute. 2F and F. Let's see. This is 2F. This is F. This is acceleration. 2F minus F is equal to ma. Acceleration is same. Generally, what people think, 2F minus F, it is a F, so the tension will be same. That is not how it works. Like I said, right? Remember, tension is not external force. If two friends pull you with F and F, do you feel comfortable? You feel uneasiness, right? So you're actually generating the same tension there. So you want find tension here, cut it here. When I cut it, I'll get two pieces. I can take any one piece. I will take the right piece. The forces will be 2F and tension. And this mass will be small m, which will be m by L total mass by total length into x. Acceleration. 2F minus T is equal to small m into acceleration. You can see how I'm drawing the pictures, how I'm writing the equations. Keep it systematic. The more systematic you keep, the faster you'll actually get it done. Most common mistake, people write it, completely. They draw the FBD however they want. They write the equations however they want. And the whole thing goes for a toss. 2 minus x by L. Clear with this? That's your tension. That will, yeah. Most of it did get it. Clear with the steps?
Yes.
Let's see one more like this. Let's say we have a 3 kg block. we have a 5 kg block. In the middle, we have a 2 kg rope. Rope has a mass now. Gravity is there. Someone is pulling this up with 200 newtons. So this point is A. A is the point connecting the 3 kg block and the rope. B is the midpoint. C is the point connecting the 5 kg block and this thing. Find the tension at ABC. Someone is pulling up with 200 newtons. B is the midpoint of the rope. C is the point connecting rope and the 5 kg. Find the tension at ABC. It's F by M. What is F by M, Rovia?
In the previous slide,
ये ना F by M था. Yeah. I hope the question was clear. In the previous question, how did we get? I already told you, Nara, unitary method. Na, Siddesh? Right? If the total mass is M for length L, then for small x, what is the length? Sure? Siddesh? Right, na? So length L के लिए mass M. So ऐसा सोचो ना, total mass by total length. This will give you mass per unit length. If you multiply the small length x, so this should be the mass of that, isn't it? Take an example. If you have 10 kg for 10 meters, then 2 meters will be how much? 2 kg, right? Unitary method, that's it. So someone did get the answer. Obia got 110, 150. Give me all three, na? Give me all three so that I can compare. Utsa, give me all three. Samyak gave me all three. Okay, we have all three from Samyak. Let's see anyone else got the same numbers. I want all three. Srihari, give me all three. Don't give me one force. Give me TA, TB, TC. I'll give you 1 more minute. Solve. Report all the three answers together. $175, $125, $150 numbers are not matching. $110, $180. Oh yeah, that's a blunder, Dick. Tension, na? When you're going from A to BC, tension can't increase suddenly. Logically, soch. Point
Sir,
A is pulling this much weight, isn't it? How can the tension decrease there? Someone said something.
sir, the first one is for A, second one is for B, and the third one is for
No,
C.
फिर भी numbers wrong है फिर भी. Siddesh, you got the same thing. Samyak, yeah, both of your answers are matching. Utsa, you have to give me the remaining also. No, Shaurya, that is wrong. Arya, tera numbers is you deleted. Okay. Anyone else? Any other numbers? I think so. Matlab, answers look like 140, 120, 100.
Sorry, sir, I didn't include the mass of rope in the acceleration.
So let's see. Karo. Okay. What is there to be sorry? There's nothing to be sorry. You'll get a -1. That is the only problem. Solve. So how do you do this thing? Step 1, choose your system. I'll take the whole thing as one system. Right? So if I take the whole thing as one system, the total weight will be, so this whole thing is one system, the total weight will be 10 kg, which is 100 newtons. Acceleration will be up. So this will be 200, that is F, minus 100 is equal to total mass is 10 into acceleration. So A is equal to 10 meter per second square. That means this whole system is going up with an acceleration of 10 meter per second square. You want to find tension at A, so what to do? Cut it at A. So for A, I'll just take the 3 kg block. What are the forces on the 3 kg block? Force F, which is pulling up 200, your own weight, 13 Newton, and point A pulls. Remember, strings always pull. That rope will pull down, and acceleration A is equal to 10. Net force is equal to mass into acceleration. So 200 minus 30 minus TA, up positive, down negative. Mass is 3, acceleration is 10. So from here, we'll get TA is equal to 140 newtons. That's how you do. Isn't that what we're doing so far? You want tension at a point, cut it there. You want tension at B, cut it there. You'll get two pieces, upper part and the lower part. You can take anything. I'll take the lower part. This will be 5 kg. Remember, since B is the midpoint, this will be 1 kg, isn't it? If you're cutting at B, it is only 1 kg ka rope. Strings will always pull. So tension B upward. The total weight will be 60 newtons. Acceleration A is equal to 10. You could have taken the upper part also. This will be TB minus 60. Mass is 6 kg into acceleration, which is 10. TB will be 120. For C, I will just take only the 5 kg block. Tension TC is pulling up. Your own weight is 50. Acceleration is A, which is 10. TC minus 50 is equal to 5 into 10. TC is 100 newtons. Are the steps clear, everyone? Since B is the midpoint, when you cut it there, the rope becomes 1 kg top and 1 kg bottom. Anyone confused with this? Please ask. It's a decent question. And it is the same thing we are playing from the beginning if you observe. I'm finding the acceleration. Wherever you want tension, I'm cutting it. Then you'll get two pieces. Then I'm taking any one piece. I'm drawing the FBD. Then I'm writing F is equal to MA. Clear, na, Aditi? Arya, now got it, na? You goofed up the 2 kg ka thing. I think then it is fine. Ovia, clear, na? Where it went wrong? Others got this? Shaurya, clear with this? Shreyan?
Yes, sir.
Srihari, got this? Utsa, Siddesh, Vanshika, Tanishka, clear with this? Clear? Let's go ahead. Let's do one more. So let's say something a little different. So that is how you can keep on finding tensions. Let's say we have a 3.5 turn spiral helix. Height is h, radius is r. So we have a bead here of mass m. So it starts sliding on the helix. Gravity is there. Find the time taken to reach the ground. First time you saw helix was in kinematics. I'll do one thing, wait. Let me ask you an easier version of this and then we'll bump up this. Let's call it 32b. Let's say we have an incline, angle theta, this is height h. This is smooth. You kept a block here of mass m released from rest. Find the time taken to reach the ground. Let's do this. This is an easy one. Then we'll go for the bead. Yeah, right, Arya. Get the helix one then. Right, Ishman. Yeah, sure. Yeah, most of you got it. Story is still the same. Step 1, choose your system. Here, the block is my system. Write the forces. We have done this in projectile, on a projectile on inclined motion. What are the forces? So if you take this forces in, the forces will be normal reaction. This will be mg ka component, mg sine theta. This will be mg ka component, mg cos theta. That's it. There are only 3 forces. Acceleration will be in this direction. So mg sine theta. So you're choosing your incline as your x-axis. Mg sine theta will be mass into acceleration. So A will be g sine theta. There, that means this block is going down with an acceleration of g sine theta. This we saw in projectile and inclined also. If this is height h, that means this incline ka length will be h by sine theta. Initial speed 0. Since acceleration is constant, I can use my kinematics ka equations. S is equal to ut plus half at square. S will be h by sine theta. Initial speed 0. Acceleration g sine theta. Therefore, time will be root over 2h by g sine square theta. You can simplify it further, but clear with this? Standard one. If you keep an incline and leave it, so there we are combining now NLM with kinematics. So once you got the acceleration, then you can use your kinematics to solve. Any doubts on this incline one? Now can you solve this helix? Now, in case you forgot what is an helix, let me just show you this. This is something I keep telling you. This was a question which you did in helix. So how do you get in helix, everyone? If you take a rectangle of height h and 2 pi r, and if you draw a diagonal, and if you fold this rectangle into a cylinder, it becomes a helix. Do you guys remember this concept? The diagonal of a rectangle, when it is folded into a cylinder, becomes a helix. This was the concept there. This was the same question, see, 3.5 tons helix. There I asked you distance and displacement. How did we do this? So when you open this, this forms a helix. So when you open this helix, it forms a rectangle of height h and base will be 7 pi r. Is this making sense? This is a concept. Have a look at this. That means you can open this helix and make it an incline. It becomes like the part A ka problem. 7 pi r root 2 h by g. Wedge is not moving, wedge is fixed. Let's not move the wedges for now. Dekhte Aryam, that might be right. I am not sure. Someone type the answer. Let's see. Is this thing clear, everyone? How we got this thing? So this is page number 10. So I will leave it there for reference. You can that is the first time you encountered an helix. So when I open this 3.5 tons helix, this actually becomes like a part of a diagonal. This will be A and B. If this was height h, this also will be height h. If this is radius r, since it is 3.5 turns, so every time you open, you'll get 1 2 pi r. So the base will be 3.5 times 2 pi r, which is 7 pi r. Done. So you got angle theta from here. Now this question has become exactly like the previous question. So from part A, we got the time. So when you leave the block here, this will go with g sine theta. So we get h by sine theta is equal to half g sine theta t square. So answer will be 2h by g sine square theta. So this will be root over h square plus 7 pi r ka whole square, the hypotenuse. Therefore, sine theta will be opposite side h by root over h square plus 49 pi square r square. There you got sine theta. So substitute here, you'll get the answer. I'll leave it to you there. You can simplify it further. So that is the catch in the question. So you have to convert the helix into a diagonal. So it becomes like an incline. And then once you know the incline, the problem becomes like this one, the first part. Clear? How are you combining two different things? So we are using the helix ka properties to make it into a problem of an incline. Any doubts on this?
सर वो जी साइन थीटा कैसा आया सर?
From here.
सर लेकिन वो तो एक वेज है.
So
सर और वो एक हेलिक्स है, तो एक्सेलरेशन अलग अलग रहेगा.
so ये क्या था?
सर दिस हेलिक्स.
हेलिक्स को ओपन करेंगे तो क्या आएगा?
सर एक रेक्टेंगल का डायगोनल आएगा.
रेक्टेंगल का डायगोनल आएगा. So रेक्टेंगल का डायगोनल ये क्या था? Then this part. तो the ring is sliding on this only ना record. डायगोनल पे स्लाइड हो रहा था.
यस सर, बट ग्रेविटी वगैरह अलग रहेगा ना.
है? Gravity will change. Gravity is in which direction? Gravity is in which direction?
सर यस सर, डाउनवर्ड.
Gravity is down. So क्या problem था?
ओके सर.
Gravity down था. So here also G is down. Here also G is down. So what is the problem? Components will remain same. No, the angle will remain same. Doesn't matter. Next one. This is a standard one. So we have a pulley, we have a block here of mass m and mass 2m. Release from rest. Find the acceleration and the tension in the strings. Yeah, easy one. Most of you must have got it. So yeah, right over here. Remember the process, the steps are same. So this thing is called an Atwood machine. Remember this, huh? Sometimes in the questions they will say in an Atwood machine. So they won't tell you everything. So you should know what they're talking about. It's called an Atwood machine. So Atwood machine is simply one pulley and two blocks. Now for simplicity, I will take it as M1. I'll take it as M2. So I'm getting a more generalized result. So what to do? Step one, draw the FBDs. So tension T, M1G. Tension T, M2G. Step two, define your accelerations. I will assume M2 is going down. That means M1 should go up. That's your constraint. Step three, write the force equations. Up is positive, down is negative. Keep the sign convention simple. This will be equal to M1 into A. Here, T minus M2G is equal to M2 into minus A because it is going down. Getting it? If you have another way of doing it, that is also fine. But keep the convention simple. Don't get confused. Up is positive, down is negative. Simple. Two equations, two unknowns. If you solve them, you'll end up with acceleration will be M2 minus M1 by M1 plus M2G. You might ask, sir, how do you know it is going down? We don't know. The science will take care of it. If M2 is greater than M1, I will get A positive, means my direction assumption is right. If M2 is less than M1, I'll get A negative. So the sign will take care of the direction. You don't worry. The tension will come out to be 2M1 M2 plus M1 by M2G. There, you should definitely mug up the results. So basically, you'll get T is equal to M1G plus M1A. Take this and put it here. If you solve this, you'll get that acceleration and you'll get everything from there. Standard results for two blocks. Remember them. Mostly mains or CET mein, so directly you can put it on and finish it off. We will see more variations of this. You won't be so lucky to get every time such an easy one. But this is your general formula for M1 and M2. Now, if you put it in the question which I gave you, it is 2m minus m by 2m plus m, g by 3. Tension will be 4mg by 3. So you can just substitute here and check it out. So remember the Atwood machine ka general result. Clear with this? Now, there is a little faster way to do, little unorthodox. Let me show you that, which can be extended to multiple variations. So it saves us some time. All clear with the equations? Next thing. Now listen to this thing. This thing I like to call it net force method. You can call it whatever you want. I just named it something. Now, when I'm doing all these questions now, I realize something. Whenever you want to find acceleration, right, the tension always gets cancelled off. So for few models now, there is a variation. And remember this thing, it will be useful. Again, we are going to use this in rotational mechanics. So acceleration, I can write this thing as net force. I'll show you some examples. Net force along the string. So you are choosing your string as a x-axis and by total mass. The only limitation for this thing is this is valid only if all the blocks have same acceleration. Let me show you some examples. Same magnitude of acceleration. Direction can be different. Magnitude should be same. Now let's see this example which we did with an attitude machine. So listen carefully here. It's a simple idea. Mathematically, it is right. So this is what I'm suggesting. This guy is pulling down with M1G and this guy is pulling down with M2G. This is going down and this is going up. So I am suggesting let's take this string and just make it flat. Matlab, I will make the whole picture like this. This is M2, this is M1. Now this whole equation looks like M2G is being pulled this way, acceleration is this way. M1G is pulling opposite to acceleration, this is this way. Can I draw like this? I will just make the whole thing straight. Does the force ka profile look similar? Now what is the acceleration here? Acceleration here will be net force, that is M2G minus M1G by total mass, which is M1 plus M2. Isn't that the answer we got here from writing all the equations? So here M2G is helping the acceleration, so positive. M1G is opposing the acceleration, so negative. So you'll take the forces along the string. So you take all the forces along the string, so total force by total mass will give you this thing. Is this looking convincing? If I just make the whole string horizontal, now see, does Max care whether the strings are horizontal or vertical? Max doesn't care. As long as the equations look same, Max is happy with it. Is this making sense? All clear? So I'll give you a few more. Now you guys try to do this method. General method, so you know anyway, find tensions and everything. You guys try to tell me the answer with this method. Let's say we have a block here, M. We have a block here, 2M. Find the acceleration of the blocks. Wages are fixed and all surfaces are smooth. Find the acceleration of the blocks. Find the acceleration of the blocks. Try. I'll give you everything. If you use this method, it will take less than a minute for everything. Yeah, right, Shaurya. Right, Ishman. Right, Arya. Get all of them. Try. I'll give you a minute for all of them. Then I'll show you. You can get them in one step. Don't think too much. You just need to do like this. You know, write the forces along the string and then net force by total mass. And you will realize this method will really shine, you know, when you have a lot of blocks. I'll show you a case where this thing is a savior.
Sir, in the D
No,
question, which block is D and C question,
doesn't
which block
matter.
is heavier?
Doesn't matter. Assume kar lena, science will take care. It is not about block also, na. Angles may be depend karega, na, Arya.
Yes, sir.
I can have M2 greater than M1, but still M1 can slide down. So when you don't know, na, assume any direction, chalega. Science will take care. Right, Ovya. Right, Ishman. Right, Shaurya. Right, Aditi. I'll show you the B part. See, listen again, in case you are little still confused about it. Step 1, write the forces along the string. How is the string? String is this, na? So you have to write forces in this direction. So this will be 2 mg. So this block is being pulling, acceleration A. This is A. Now tell me one thing. This block of weight mg is in which direction? Downward. Is this pushing it in the horizontal direction? No, right? So that mg is not helping you. Bas ho gaya. Matlab there's only one force which is pulling you down. So acceleration will be net force which is pulling down, which is 2 mg by total mass 2m plus m. Are you getting what we did? This block of weight is pulling the acceleration. This block of weight is not doing anything. It is not supporting, it is not opposing. So that weight is useless. Any doubts on the B part? Please ask me. So you need to take the weight components which are along the string. So the B part is like your friend who comes to the, he comes to the party but doesn't bring anything. He'll eat and go. So all the work is being done by this 2m only. What about this guy? Look at this. The forces will be m2g. So you're taking forces along the string, you're getting it. So this force will be m1g sine theta. We don't know who is going down. So I'll assume m2 is going down. So this will be A and this will be A up constraints. So look at this. m2g is supporting acceleration. So plus m2g. m1g is opposite to acceleration. So minus m1g sine theta by total mass. Are you getting how we're doing this? What about this guy? Along the string. So what is this component? m2g sine theta 2. What about this guy? m1g sine theta 1. We don't know which way it is going. Assume whatever direction you want. I'll assume m2 is going down. So m1 has to go up. Acceleration. m2g sine theta 2 is supporting the acceleration. So plus. m1g sine theta 1 is opposing the acceleration. So minus by total mass. Are you getting this? No need to write any equations, nothing. You can just put it there and get the acceleration pretty fast. This will give you the magnitude. Anyone confused with the sign? Why did I take minus? Why am I taking like this? Anything that you're not convinced, please ask. Quite useful, saves you time. Clear with this? Clear, na, Shreyan? Sidesh? Utsa, clear with this? Aditi, Advai? Devanshi? Rudransh? Pratyasha? No, the actual question. There are 6 blocks. Let this angle be alpha, let this angle be beta, and let this tension in the string, let this be tension T. Find the acceleration of the blocks and the tension in that part of the string. Now, if you see all the blocks are connected by a string, so you can see all will go together with the same magnitude of acceleration. So I can use this method. Find acceleration and tension T. So T is the tension between third and the fourth block. Now, if you try to solve this normally, you have to draw 6 FBDs. But with our method, you'll get the answer in one step. Try. You got a minute or two. Tension is an interesting one. Acceleration is still fine. So I had to come up with this method when I saw questions like this. The regular one was going too big and hopeless. And I said, yeah, we can do this in a much faster way. Got the acceleration m2g, m1. Right, Samya. Yeah, but you took m6, m5. That is right, Samyak. You are right. Shman. M2 you moved up somewhere. Neresh, when you moved up. M2 and M4 will not be there only, na. They're not helping you, they're not supporting, they're not doing anything. M6, M5, right, Arya. Yeah. See, you need to see whether the MG is giving any force along the string. Now look at this. So let's assume any direction you want. I will assume 6 is going down. So this is going down this way, this is going this way, this is going this way, this is going this way, and this is going up. Now look at the forces. M6G is actually helping you. It is pulling you down. Great. M5G, so you have to take the mg ka component along the string. So this will be M5G sine beta. This is also helping you. M4 is doing nothing. Mg is vertical, so there's no component. This will be M3G sine alpha. M3 is helping you. M3 is also doing nothing. Mg is perpendicular, see 90 degrees, so that is 0. M1 is actually fighting you back. That's it. There are total 4 forces along the string. So acceleration will be M6 is supporting plus, M5 is supporting plus. If you have taken the other direction, then this will be negative. It is okay. M3 is also supporting. M1 is opposing. This is the total force along the string by total mass. Clear with this? So you take the forces along the string because they are the ones who are responsible to make you move. If the gravity M2G is this way and tension is this way, this M2G is not helping the tension or not opposing the tension. It is useless. It is just there. So it is not responsible for any motion though. Clear with this? What about the tension? Again, I keep saying this like a broken tape recorder. You want to find tension, what to do? Cut off there. So if you want to find tension, cut it here. So if you cut it here, you can take right piece or left piece. I will take the right piece. So this will be the tension. This acceleration is A, this acceleration is A, this acceleration is A. We just know already found it. What are the forces? M6G. This force, M5G sine beta. M4G will not help you anything. So what is the acceleration? Same story. M6G is helping you. M5G is also helping you. The tension is opposing you. So the tension is like a new force by total mass, M4, M5, M6. Is this making sense? I already know A ka value. Substitute here, I'll get the tension. See, Max doesn't care whether there are 100 blocks here or there is one force called tension. Max will simply think tension is also a force there. Other steps clear, everyone? So you want tension there, cut it there. Treat that force as a new force tension. Now the problem has become 3 blocks. M6 is supporting, M5G sine beta is supporting, M4 is not doing anything, and tension is opposing. So total force along the string is this by total mass. Any doubts on this? All clear with this? Okay, that's a pretty good one net force method. So do remember this, it will be quite useful. But like I said, it has limitations. If the accelerations are not same, next class we are going to see these things. If I give you questions of this sort, we have a block here, we have a pulley here. Now, if you see, both of them will not have same acceleration. So you can't use the methods here. This will fail. So this thing is a special case. It works only when you know like all are going with the same acceleration ka magnitude. Let me ask you one more like this. We'll wrap up with that. Let's say we have a block of mass m. Someone is pulling with a force 2 mg. We have a block of mass m. This is 2m. We have a block of mass m. We have a block of mass 2m. And someone is pulling, let's say this is also m. And someone is pulling with F is equal to 2 mg. Can you find the acceleration of this left block in all the three cases? Gravity is there. Gravity is present everywhere. Again, net force method, you'll get it in one step for everything. Finish off, last one for the day. Get me all the three answers. A and B will look similar, but A and B are not similar. They're very different. G by 3 2G. G by 3G. Okay, let's see. So this thing is mg. This is acceleration. That's it. So what is the net force along the string? The net force along the string will be F minus mg by total mass. Total mass, there's only one block. This will be g. This is 2 mg. This is mg. See, the forces will look same, huh? So here the net force is 2 mg minus mg. That is right. But the total mass is m plus 2m. So in A and B, the force is same, but the mass is messing up. So this is g by 3. In this case, the force will be your own weight mg, and this block ka weight is also mg. So the net force will be F plus mg minus mg by total mass. That will be also g. Got this? So in case A and B, the forces are same, but the mass will mess up the whole acceleration. Easy stuff. I hope everyone got this. There, that's a bit about it. So next class when we catch up, we'll continue from here. We are going to see actually much better problems now. Today we saw things started moving, right? From equilibrium, now we started moving things. And these are all just going in, simple motions. Next class will be a little more complex stuff. So we have done almost 34 questions. So please make sure to go through the whole notes, right? And yeah, I think we should be able to wrap up this thing in another 3-4 classes. Okay, with that, we'll wrap up for the day. So any doubts in today's class notes? Any other doubts, please stay back and ask, or else you're free to leave. So do remember, there's a test online till Thursday night, so make sure to give it.